Let's press the share button. Cool. I'll move this out of the way. Okay, just a quick sanity check. Can you see my screen?
Yes.
Okay, fantastic. So today I'm going to walk us through the two chapters on proportions. The first one on just kind of basic proportions, and the second one on nested proportions. I've got, I guess, some extra stuff at the end, perhaps, which maybe will open up into a broader discussion. Right. So I kind of have read these chapters a couple times over and was trying to think about really what is the author telling us to do. And I kind of feel like this little snippet summarized it for me. In essence, is basically like for all things that are marginally complex, it depends is the answer. So what should we do when visualizing proportions? It depends. And I think helpfully in this sentence, this is depending on the features of the data set and the specific story you want to tell, you may want to favor one approach over the other. So in short, it seems like there's no dominant solution for data visualization. I know that's a real shocker. But I think particularly it seems to be the case for proportions. And the author's, I think, choice of examples kind of drives home that point. I don't think I'll be able to do as nuanced a discussion as the author did in the chapter. So definitely encourage you to look at the chapter, but I'll try to give a summary overview. So in looking at proportions, he kind of suggests a few things that we could do to approach proportions. One is the first one I think is probably the most controversial in the I guess the DataViz community is he tries to make a case for pie charts and talks about where he thinks it works. Let me see if I can adjust the size here. I think many people kind of discard pie charts out of hand because I think they've been overused, and there are also some perceptual problems with pie charts. But I think maybe it's just they're overused in business applications, and people kind of poo-poo them. But he actually says that they seem to work reasonably well when there are relatively few groups that we're looking at. So if we're looking proportion for group A, group B, group C, pie chart can actually do okay. And then additionally, he says, I don't remember whether it's entirely directly, when there are kind of simple fractions involved. So this looks kind of 50%-ish, right? So I can tell that that's a certain percentage. Others, here, for example, I'm not quite sure what this percentage is. So even in this chart where part of it works and another part doesn't, you can kind of see in this single example kind of where it can work and then also where it falls apart. And then this is a part I think I added just to build on that simple fractions thing, or maybe kind of flesh it out, is I think when pie charts work when there's like a perceptually obvious pattern, right? So I think pie charts, the common issue with them is that it's really hard for humans to judge kind of was it radial or polar area. So I mean, what percentage is this? It's kind of hard for me to tell. And I mentioned already, this is really hard to tell. I can tell how many seats there are here in the German Bundestag, but only because the authors put a label there. I really don't have a clear notion of what percent this is, nor this exactly. I'd venture to guess it's 40-ish% or something like that, 30s to 40s. But here, I think there's an obvious pattern where you have this political party, or I don't know if it's family of political parties. Forgive me, I'm not well steeped in German politics. That compose basically the near majority. And then the other part, which he comes to later, is that if you total up the seats between these two political factions, you can basically get to 50% or slightly greater than 50%. This would constitute the majority. So there's a pattern that emerges from the data that makes it such that pie charts in this instance actually work. But they may fail in other places. Here's my horrific Excalibur quick sketch. I think there are many more cases where I think pie charts don't work. The author doesn't say this exactly, but I feel like this bears saying, is that when there are more groups, or it doesn't say all of these things, but I think when there are more groups, pie charts kind of fall apart. Because I think it kind of engenders this problem where you end up with lots of little slices of the pie, and you're unsure how those slices compare relative to one another, right? And certainly like how the size of the pie charts corresponds to an actual underlying number, unless they're labels. Additionally, and I think I didn't say this below, comes the problem of labeling. The smaller the slivers of the pie, the harder it is in practice to kind of describe those slivers of the pie if they're meaningful to describe, right? This is a just kind of laughably small sliver of the pie that I created, and you can imagine it might be challenging to place a label pointing to that unless you're doing it kind of by hand, or if ggREPL for I guess our users kind of solves this problem. Um, and also even like one of the nice features of pie charts when the fractions work out is sometimes you can kind of tell which is the biggest and which is the smallest, but for some divisions of the pie, it's really hard to judge. Even though I created this, I'm honestly not sure which is the bigger slice of these four right here that I'm kind of waving through. And I think any of us would probably be hard pressed to figure that out. So that really, I think, points out a failing of pie charts. Um, there are other
Could
strategies
I
for kind
ask
of,
one
oh
question
yeah,
about
sure, please
the
do.
graphic? Sorry, is there a raise hand feature in Zoom? Should I be using that or?
Even if there
Sorry,
is,
Gabby,
feel
you
free to
look.
jump in. At
Okay,
least
I'll
for
jump
me.
in anyways. But
I was muted. There is, but it's usually we just start talking. I
okay,
mean,
cool,
yeah,
cool.
it's sometimes it's kind of hard for the person that's leading the chapter to start, paying attention to all those things.
For sure, for sure.
But it,
Just about the. Oh, sorry, Gabby, I didn't mean to cut you off. You could
no,
finish your
no,
thought.
no, please. It's in
Okay.
React. You go to the little heart where it says React, then you'll see the raise hand. I'll show you with me there.
Oh, okay.
You just start talking. It's just five of us today.
Oh, okay. Yeah, yeah. Okay, I see it now. Okay, great. It's actually for the first graphic, the one that's from the chapter. Um, I was kind of like, I had a kind of epiphany moment when he's like, if you look at the first pie chart again, you'll see that the CDU, CSU is like a minority, and that the FDP, SPD
Is the minority or
coalition
majority rather, yeah.
majority. Yeah. But maybe it's just I'm not used to reading graphics like that. Like I didn't think about proportions when reading this, even though I guess that's the whole point. I just looked at like what slice is biggest, CDU, CSU, what slice is smallest, FDP, and like went on my way. Did anyone else like immediately read this graph as CDU as a minority, if you consider a coalition between FDP and SPD? I
No,
suppose
I
you did,
figured like
Gabby.
this would have like whatever the form, I think this would have been like the author seemed to think this was obvious, and I guess he's a German national.
Okay.
But for me, I felt
Yeah,
like
with a name like
whatever
Klaus.
form you'd want to highlight that. You would somehow want to highlight around this block, and that might kind of, and then probably have a title or subtitle that kind of communicates that message. Because just like for you, Josh, this did not jump off the page to me. I had to find it in the author's writing, and all of this, what seemed like, so you kind of came to these other attempts to kind of unseat the pie chart, and I thought they were perfectly fine, but he was trying to argue that they weren't as good as the pie chart because you couldn't come to that observation as easily. And I'm not sure I agree with that. But yeah, like you, I felt like it was not obvious to me. Yeah.
So
Okay.
if you pay attention to the middle line,
Yep.
so it looks on the bottom between the gray, I guess that's gray, and red, it's a little askew to the
Yep.
left. So I if you tell me that if I put together FDP and SPD, then I can see that it's just those two are maybe 51 or 53% over CDU, CSU. It's just because it looks a little askew, but it's such a small difference that it might elude the majority of people. I mean, it's just because I see the straight line, and then it's just like a little off kilter. I don't know how you say that in English, a little
Yeah,
off
exactly. Yeah.
to the left. So it may not be so obvious, especially if you have this printed and it's like a smaller chart, or if you are projecting that in a conference room and it's already like, how sometimes it looks not pixelated, but it looks sometimes a little like off or something. So yeah, it's kind of weird.
I would have felt actually that the better way to argue for that would be something like this. So if you could have here, I guess I'm thinking of American election results and maybe results for others, but like when first past the post systems, You know, it's like if you could draw a line that showed where the majority was, I think that would be a lot clearer in something in a stacked or horizontal kind of stacked chart of this sort. Here, I just feel like the problem is, and I've not worked with pie charts much at all. I've kind of avoided them like the plague. Is you know, I kind of feel like it because this is near vertical, I might kind of get the sense that this is a little askew, right? But imagine that the orientation was different, that, you know, it wasn't kind of along these axes. I'm not sure if people could actually pick up on that difference. And I'm not, I mean, I guess as a DataViz designer, you could probably order the slices of the pie in such a way that that pattern is maybe more perceptually obvious, but even yeah. But I feel like you know, if you're just kind of mass producing these kinds of things, that would you would fall short, and you might be better served by something like this. Yeah, I think the author kind of argued that these were sort of inferior just because you don't get that what is the term? Like when anyway, like that I can't remember offhand the technical term, but it's sort of like your eyes and mind do some pre-processing of an image before you kind of even learn it. So you can uh yeah, sorry, I lost my train of thought. But for these, I just feel like these are better to my lights. Yeah. And maybe the labels could be changed, or we could just have a vertical line right here that would show where majority lies. And then you could probably see that this coalition or single party uh, falls short, falls slightly short of majority, and that this coalition, if they form as a coalition, could be the majority, right? I feel like that would be a far better way to do it. And I think to this point that later in the chapter, there's this nice example of kind of a series of stacked bar charts which showed the male and female composition of the Rwandan parliament. That I think is what should have been done here. In that case with the Rwanda, I think the point of the graph was showing the percentage of male and female members respectively over time. But I think that same strategy would have been effective here if we just drawn a line that said where 50% lies, and then or the requisite number of seats to be at 50%, and then I think it would have been a lot better in this case. Yeah. And I guess so like the other alternate strategies, you could do this. I still personally feel this. I like this strategy a lot better than pie charts because I feel like it's easier to read, easier to kind of judge size, and better accommodates labels that would facilitate, or I guess tick marks that would help in judging size. And this is another strategy of side-by-side bar charts, which you know, shows, I think it solves the problem of you can see which coalition is the biggest and by how much. That's really helpful here. But you don't see this fact that if you stack this on top, then you would have a majority, or you'd have a larger number. Here you lose, I guess you get a good judge of the respective size of each one of these, but you lose this kind of part to whole bit, which the author kind of goes into. So it's good for kind of magnitude and ranking, but not so great as kind of judging the relative, I guess, well, the proportion, like what proportion this constitutes of the whole, because you're just looking at absolute magnitudes, not in this case percentages. There's another thing, this is my own addition, that the author didn't talk about. I know, Gabby, I think you in the past you'd expressed your fondness for waffle charts. I think these do probably just as well, if not better, than pie charts. Because you know, at least here, I think it's maybe a little bit easier to judge kind of like the size of the pieces. And you don't have to. I don't know. Maybe it's a toss-up. I mean, personally, I kind of feel like I can judge the size of this, even though it's not a regular shape. I can still judge size of things a little bit better. It's better than judging like radial area. But I feel like reasonable people could disagree about this. But I just think waffle charts might be better if you wanted to go down the pie or donut chart alley. Reach for a different suite. Incidentally, this resource is where I've drawn it from. It has some really nice sketches of lots of DataViz designs and maybe some brief arguments for and against. So it's a nice resource to have in your back pocket.
Is that a government UK?
It
They
is,
have their
yeah.
own DataViz guidelines?
I'm not sure what exactly this is. It's definitely government of UK. I'm not sure what status it holds, whether it's a guidance document, I think it's just like a simple guidance document rather than like a style guide, but it's kind of nicely done. It's
Yeah,
nicely
it looks
done.
like it. Cool. I will check it out. Can you drop that just in the chat as well?
Yeah, happily.
So you got that link open. Thank you.
Oh my God, I love that book. Maybe that should be the next thing we read. I love it.
They've got some good stuff. Whoops, sorry.
Yeah, the visuals are very fun. Very
They
cute.
are, exactly. They're very engaging. That's another thing I think I tend to like, much as I really appreciate the kind of practical, let's say reality-based examples in this book. I also really enjoy designs that kind of representations of chart types that are, how to put it, like low resolution, I guess you would say, like if you're doing like a wireframe for a website or something. It conveys the idea without overwhelming you with the detail or bogging you down with the details. So this is pie charts, and then my waffle chart edition. The next bit was, okay, so like one strategy of dealing with simple proportions is pie charts. Another the author puts forward is side-by-side charts, side-by-side bar charts. And kind of the way I read it in the exposition of the chapter is that it's not necessarily a good strategy, it's less bad than the alternatives in this particular case. So it seems like the kind of the use case would be you have several, well, at least the use case he puts forward, and I don't think he means it to be like a generalizing use case, but it's helpful, is let's imagine you want to look at like the market share of, in this case, market share of particular companies over time. One way you could do it is to brandish your old friend, the pie chart, and you can see that this is really not helpful at all. They look like, I don't know, like Mac OS color, like the weighting symbol or the color wheel or something like that. It's very hard to judge changes over time. And, because there are so many groups, even for this pie chart, if you take a particular time t, it's even hard to judge there the relative proportions because there's not this kind of overwhelmingly obvious pattern that emerges. So author labels this as bad. Another alternative he puts forward is like, okay, well, let's do side-by-side stacked charts. I think this is not terrible. He labels this as bad. I definitely see the deficiencies of it, but still it conveys some information that was missing in this previous example. So it's the same data, just using a different viz strategy. Here you can kind of see, for this company A, that market share has increased over time, right? For some of them, you can kind of easily discern changes in market share over time. So that's kind of helpful. You can see this trend across these three years. But it is difficult to judge, for example, because there's not like an anchored baseline, for example, like this blue, this light blue, does it change? And if so, by how much, right? For the ones that are kind of at the extremes, you can kind of discern, or when they're big movements, you can kind of discern changes over time, but it's a little hard to parse. And then also, I think the problem that we have with the pie chart holds here still is like with lots of groups, it's even difficult to understand the relative proportions for any given like time t, particularly when they seem to be, I wouldn't say equally distributed, but not far off from it, right? But one way in which you can make the kind of side-by-side bar charts work for you is if you group them in a thoughtful way. And here the author, has this example where if you have one group per time, you can. His argument is that you can more readily gauge changes over time. So if I look at this orange bar, I can see that its market share has gone up, and I can do so for every single bar. If I kind of serially look at the bar, I can see I can see. And then also within each time t, I can see sort of like the ordinal ranking of each company in this case. I think that's right, but I kind of wonder if you could do better than this. The author didn't say this, but this is kind of my own judgment at play, is what if you actually grouped the companies, if you group by company rather than by time? Then you could actually see, I mean, maybe you might give up on, so here I think the sacrifice is, I mean, maybe here the story, I don't know what the story would be here, but here certainly the story would be you were looking at changes over time for each company, right? And so if I reorganize these bars, and these have no mapping to the data, I just kind of drew some bars with Excalidraw and kind of filled them in. You can see that there's a trend. You can see the trend or lack of trend for each individual company, right? And I feel like that tells, at least to my mind, like a clearer story. What you do miss out on is kind of like the composition for a given year, right? But if you went in this direction, almost you might want to step away from bar charts entirely, right? If you're only looking at changes over time, perhaps a line chart, some kind of indicative line chart like this might be just as good. And then maybe you could simplify even farther, which I didn't do, of rather than putting these in facets, put them all in the same graphing space, and then maybe you could kind of see how companies changed over time. Anyway, these are just my own musings based on kind of riffing off of the example of the author, because I see this a lot in practice, and it's kind of hard for me to disentangle whether it's just my general dislike of this kind of approach that's coloring this, or whether actually this is not that great DataViz strategy. It feels to me very, very busy, even if you put to the side the colors. It feels very, very busy, and I feel like if I, as a consumer of the chart, want to come in and understand the story, it requires more effort than I would want as a designer consumers to expend. So if I want to see like the trend for a given company, I have to go and like visually move my eyes across these charts, finding the relevant bar, and then try to parse a pattern. I think that's probably asking a bit too much. But again, it depends on the story you want to tell. If you're looking at kind of within time and then you want to hint at over time, maybe this isn't terrible, because here I'm looking at, for a given company across time, but then like within a moment of time, it's very difficult. It's equally hard. It's hard to parse in the same way that it was hard to parse kind of like the cross time for this chart. Yeah.
For that graphic from the chapter, yeah, this one here, I had the same thought as you did, just to switch the facet and the x-axis. And you said you weren't sure what the message here in this graph was, and I wasn't really either at first. But looking at it now, I wonder what folks think of like the message being there were winners and losers in terms of market share in 2015. E like won, A didn't do as well, and there were winners and losers in 2017, but like everyone kind of did the same in 2016. Does that feel like a fair interpretation of this graphic?
I think it does. And the other thing that you can do is highlight things by color. And you can just, if that is the story that you want to go with, then you can just highlight the winners and losers for each year, and the rest can be all grayed out. That could like minimize all the saturation of color or all the different colors, so that you're like, where do you want my eye to focus on? So if that's the story, like look at the winner in 2015 and the loser, or that there was like a variety here, whereas in 2016 the difference is less, then maybe that could be a way. But I think that that's more, yeah, like it's always I think smart to think about what do I want to convey with my graph, and then like what you were saying, Arthur, and then just stay focused on that, because maybe you don't care about across years, but you want to see differences within each company than you do the other one. Like you, exactly what you were just saying. I'm just repeating what you said.
Yep.
So I think it's a good thing that you're doing right now, because it really brings back the fact that the message is more important sometimes than the graph. So the graph is
Yep.
just going to help you tell the story that you want to tell. So
This
yeah.
feels like to me like a table in graph form, in the sense that it's a bunch of numbers, and then we leave it to the reader to kind of squint hard and figure out what pattern they want. which it feels really lazy. I mean, unless the story is meant to be as Josh said. I mean, there it's maybe a bit more reasonable to adopt this strategy, but I see this just way too often, where I'll have lots of groups, and I think many people end up happy because they've got a graph and it feels like, yay, it's not a table, but sometimes I feel like you really need to think about what your graph, just as you're saying, Gabby, like, what is the message? What is the message? And then design a graph that clearly conveys that message, or conveys it as clearly as the data and other constraints allow. Yeah. All right. This I thought was a brilliant example. I really love this one. This is what I was referring to when we were kind of talking about the German Bundestag. Here, it feels like, if I took any time, if I just took this 1 year right here, so I guess it's clear that men are in the majority, right? And it wouldn't change anything if I kind of segmented this men into different kind of men, or women into different kind of women. If I can see that a grouping has made it past the 50% mark, it's clear who the majority is, right? So this is kind of the stacked bar charts example. And the author makes the point, like, this is maybe kind of like a limit case, like a helpful limit case. So we may find pretty often, politics in the US, Democrats and Republicans, or, I don't know what other context is the one for being an American. It's the first one that springs to mind for me. But this is kind of like a nice kind of like limit case where you have a small number of groups, 2. But you have like maybe the opposite, like, limit case, where the author kind of says, like, well, let's take densities to effectively be like an approximation of like almost infinitely many number of bars, right? So you can imagine this just being like a bunch of bar charts, and then the line just kind of is a smoothing of that. And this also works, but it's kind of maybe borderline in a certain sense. So it's nice when you have, the author says, when you have relatively few groups. So here we have four groups. That seems to be, in this case, manageable. Although I could easily imagine this, like the pie chart at the beginning of the chapter, this could depend on the story that emerges from the data. There may be configurations where this just doesn't really do much, right? Or where there may be confusing patterns. But in this particular case, you can kind of see some broad trends. Although one thing that's conspicuously, one thing that's really hard, you can see, for example, for poor health, it's really small and then kind of sharply increases as with the age of the population. But what's not obvious from this graph is that good health, so this band, remains essentially the same level throughout. It's a little harder to discern from this particular graph. So you can kind of see for those cases where there are sharp changes, just like in the case we could with the stacked bar charts here, right? So for those where there are big changes, you can discern a pattern. Where there are more subtle or no changes, it's very difficult to understand what's going on, if anything. And then just like the movement of the line makes it hard to, like, here, it may seem like there's a change, but in actuality, the author goes on to demonstrate there's really not much of a change, except on kind of like the tails of the ages. Yep. So the author goes on to suggest another strategy. And I have to say, I think I like this one a lot, but I've not thought enough to see whether this is like something approaching a dominant strategy, but I quite like it. Is, focusing in on this, if we're looking at proportions, we're kind of looking about like what part of the whole. And one thing that you can do is you can kind of have, I guess you can call this like implicit proportions in a certain sense. You can graph in the background in gray the total number of observations per age, so it's density, and then you can look at the density for the highlighted groups. So in this case, in this panel, in this facet would be never married, and this one married, et cetera, et cetera. So in this way, you can really kind of see these trends in time. At the very least, very clearly trends in time within group. So you can see that, the never married kind of peaks, let's see, maybe mid-20s or something like that, and then falls fairly precipitously. And then, the widowed, people with marital status of widowed, increases at the moment you would expect it for life cycle reasons. If they were married, spouses may begin to die, and so that population of widowed respondents would rise. So it's really useful in that sense of kind of like discerning for any given group, like the part versus the whole over time. But I think where it does less well is kind of measuring like the relative proportion of these groups. So for example, like I can see the count right here, but without doing a little math, it's hard for me to discern like how much of the population at this point in time is never married. I might more easily be able to discern this perhaps if I had a facet and it were column oriented. And so all of the axes lined up and I could kind of draw a visual line down, perhaps. But even still, I think it would be a little hard to judge here. Yeah, I guess the other part here is where it's what I call like implicit proportions or implicit percentages. We're kind of like our eye impressionistically determines a percentage, but there's no percentage here because these are actually counts. Everywhere, this is counts. But we could take the same idea and convert it to relative proportions. So we could take these same data, preserve the idea of faceting, and then rather than displaying counts, we could look at the relative proportions. And there we can more clearly see that what seemed a little bit the case, but is hard to determine here because married starts in pretty early within this density as well, within the overall density as well, is that, never married, how much of the population it constitutes at this particular age. And relatively speaking, like how much the widowed population is for that age group. But yet again, I think, it's nice when it's arrayed this way, but somehow I'm still wanting to see this maybe ordered in a column format, perhaps, but it still may not give me quite what I want. I think percentages here are kind of tricky. And in the next chapter, the nested percentages grow trickier still, I think. Let's see, so on then to nested proportions, this kind of nested Russian doll. So you can kind of imagine like you have a percentage and you want to look at the percentage of something within it and within it, within it, within it, etc. Maybe not the best visual metaphor, but definitely got the nesting clearly there. So sorry about that. So I guess you've all heard maybe the Latin expression like caveat emptor, and this is me going through ChatGPT to figure out like, beware, buyer beware. Well, this is like the visualizer beware. So I think there's a segment during the chapter where the author kind of says, look, nested proportions are tricky because, a naive approach, you might just take all these percentages for each kind of group and subgroup within groups and then try to naively put them on a plot like this, and then you'll see, although it's not super easy to discern, okay, maybe it is, that this sums to well over 100%. That's not good. So you don't do that. So basically these kind of like traditional patterns don't work, and we have to go reaching for other things. The author suggests a few, and then I'll at the end kind of suggest a few others that I happened across without looking at them too deeply. So he points out kind of three families of things: mosaic plots / tree maps, nested pie charts, and then parallel sets. I went looking for others because, frankly, after reading this chapter, I was left unsatisfied with what was presented there. I'm not saying it was bad. It's just that it seemed like it didn't really address the problems, or I don't like some of the, just personally don't like some of the solutions. So one example would be like mosaic charts. And this is maybe a case where you have nested data where each kind of area or each kind of unit group of interest belongs to like one, two or more subgroups. So in this example from the chapter, he looks at bridges, I believe in Pittsburgh, and wants to kind of look at bridges by their era of construction. So it's these crafts emerging, mature, and modern eras. I guess that means something for art historians / architectural historians, if such a thing exists. And then what material the bridges are made of. So each one of these blocks is kind of like a combination of those two attributes. So within the crafts quadrant, I guess I'll call it, you can see that, most of the bridges of that category are made out of wood. Yeah, and so on and so forth. Or sorry, I should have said within the category of bridges made of wood, most of them are from the crafts era and relatively few from the other eras. Within steel, it's a little bit better split, but still the vast majority are considered mature, whatever that means. So the idea is to kind of, grapple with this parts of the whole by saying, like, first, let's take an area, in this case, a square area, eerily reminiscent of waffle charts in a certain sense, and then subdivide it at the first level of, steel. So like this is the area of all steel bridges, all wood bridges, all iron bridges. And then within those groups, try to segment it further to show like within that larger group, the relative proportion of bridges that coming from a certain era. Something that's very similar to this is the tree maps, where if I read correctly, and at this part I really just kind of read really quickly, so perhaps you can correct me on this, is that each child belongs to only like one parent group. So there's more like this hierarchical structure. So each state in the United States belongs to one of these four regions. And I think we're looking here at the relative population of those regions, or I don't know, maybe it's actually geographical area. I don't know what it is. Probably geographical area. And yeah, so it's different here, whereas previously in mosaic charts, you have them belong to two or more groups. Here it's just one group, one parent group. Problems with these, and I think these are the reasons that kind of maybe a bit averse to them to the start, is just like they're hard to parse. They get visually busy very fast, particularly as you label stuff. And then I think it's just as it is the case with pie charts and others, it's really hard to judge the size of things, particularly as you're dealing with irregular shapes. So for example, Washington is very long and narrow. How does that compare to Oregon? I'm not sure. I really don't know how to compare those things too well. I still think Oregon is bigger, but it's hard for me to discern because they're different shapes. Nested pies. So the author kind of came up with this one strategy, and I'll come back to another later time willing. Is that basically the idea is, so if what we could do is we could basically take every combination of groups and make each one of those a slice in the pie. And then we could kind of easily discern like the relative size of these. So here, all mature bridges that are made of steel, that's this big segment. All modern bridges that are made of steel, etc. And with color, so here you have these labels that indicate this like combination of two categories. And then the colors allows you to kind of understand the parent category. So these are all steel, blue steel, green wood for some reason, orangish iron, etc. Not bad, I would say. More labels than I would want, but it conveys information. And I think here, the author, I think, really is an advocate of putting numbers on there so you can kind of judge. I think these are actual counts in this case. Although maybe not. I think these might be percentages. Makes it a little easier to judge. Another idea he had, which honestly I feel like kind of doesn't really work, at least for me, but maybe I'm just conditioned to look at this and think this is a Sankey or alluvial chart, is to use parallel sets. So you can kind of see like of all the wood bridges, the vast majority of them are medium in length, I guess, or height. I don't know what this one, this is a new, oh yeah, length, there we are, length. And then a small number of them are short. And you can kind of see how these map to different categories. I feel like this might work if there are interactions here. With it just being a static graph, it's really hard for me to follow. And also, I'm kind of frankly used to looking at these more in the case of, let's say, like some kind of dynamics occurring. Like, let's say I'm looking at a panel data set of households moving into poverty or something like that. And then there I can easily see like where a larger group or a group from time zero, like how so almost like a transition matrix, like from a state at time 0 to a state at time 1, et cetera, et cetera. Here, kind of weaving these parallel sets through different attributes somehow doesn't work for me, but that's just my own opinion. I guess, sorry, I'm talking way too much, but on now to another thing. These are kind of the ones I came up with out of dissatisfaction or being left a little bit, can't think of it in English, but a little bit wanting from the previous chapter. Sunburst charts, nightingale charts, and then a few other strategies I'll kind of go over quickly. Sunburst charts, there's this really nice article that I point at the bottom right here. Whoops, I need to recompile this. That kind of goes through a worked example for our users. So it's really quite nice, but I just kind of plucked out the images here. So there are kind of two sites of sunburst charts as I understand them to be. One is where essentially if you look at there's like an inner circle and there's outer circle. The inner circle is basically a pie chart or really a donut chart because we've got an empty center where you can kind of see the first grouping. And then on the outer ring, you see subgroups of this larger grouping, right? So all this purple and like hues of purple belong to this purple group, etc. So it's not bad, but I think we're going to run into a labeling issue. I think this would probably be far more effective as an interactive chart if I could kind of hover over the segment or subsegment of interest and then see more about it. But it's not bad. And then you can also do these varying length ones where I think that the length of these bars, it's kind of almost like a radial histogram where the length of the bars actually brings in another data layer. So in this case, I think it's some respondent about rapid review of the article, looking at different sectors. I think purple is software engineers or something like that. And there are different kinds of software engineers. And then the length of the chart corresponds to their median salary, right? Interesting, visually interesting. How well it conveys a message remains to be seen. And here there's some nice resources here. It turns out there's an R package for doing this. I've never used it before, so I can't speak to how well it does it. An extended example and then another little link. This I found interesting because I've seen it in the past, but I've never thought about it. It's something that's called, I guess Brits call it coxcomb or nightingale after Florence Nightingale, who created these charts to look at causes of death during the Crimean War. And here you've got everything radiating from like out of a central point. That's sort of almost like a radial histogram in a certain sense. So you can see the absolute number of deaths gives you the kind of the length of these bars. But within the length, you can see the percentage and probably also like absolute counts in a certain degree, but let's say proportion of deaths stemming from certain factors. So each one of these is a month of the year. And then you can see the absolute magnitude of deaths and then the sources of death. So we've got blue coming from preventable diseases, that being her point of interest, red from wounds, and then black all other causes. I thought this was kind of interesting display. Another thing, this is something I just threw together quickly from work, from fake data, looking at like household size in Burkina Faso. And I was thinking like many times if we're looking at kind of like nested proportions, maybe we don't want to see all the nested proportions at once. If there's a story or if there's something that's of focus, maybe what you could do is actually pick out one group and then look at subgroups within that group. So here, I've actually not done this as subgroup analysis or drill down, but let's imagine that you wanted to see Centre Est. You wanted to see here, like I can see overall it's 5.5 members per household. And then I wanted to look within the rural and urban subdivisions of that region. So you might be able to have like an inlay chart where you could see a trend for like the first level group and then see for like the second level group, the stats for a particular group of interest, right? If there's a story to tell. Not everything at once, but just to focus on the story to tell. And to that point, I think really the ultimate solution to my mind is like this interactive drill down. This is not the best example, but it's from the Quarto docs where we're looking at this is for the Palmer penguins data set. demonstrating observable JS. But here, like let's say I just cared about, the dream island, right? Then I could look at that particular thing. Or I wanted to look at larger bill links on this island and so on and so forth. It allows me to kind of look for that thing that's of interest to me as a reader. I feel like that would be the ultimate thing for these nested proportions. I feel like they're really difficult to display otherwise. And after that very long monologue, I'll stop. That's all I've got.
No, thank you, Arthur. That was great. I think honestly, proportions are one of the most common graphs that we're going to see, especially when we're talking to Gen Pop, right? Like when you're communicating science or anything to general population, usually it's going to be in the form of proportions. So I think it's a very good exercise to start thinking different ways to visualize proportions because it's one of the most used graphs or ways of visualizing data. I also put on the chat other things that can, or other graphs that can help us visualize proportions. I think in the end, it's a toss-up between aesthetically pleasing charts and something that will convey your message really, really well. So these are radial charts. So this is think about bar charts, but they are just curved. So
Yeah.
again, it's the same thing. You can present it in like in bars, horizontal or vertical. But then this just adds a little bit of, I don't know if whimsical is the right word to use here, but it adds a little bit of aesthetics or something, right? It's essentially the same thing. The two last links that I put. And the other one is the donut charts, which is the one that you showed, is just another example of how you visualize the proportions. It's the same thing that you mentioned.
Yep.
Just let's try to also note that people call them different things. So that's another thing that we have to keep track on. Is it a donut chart? Is it a Nightingale chart? Is it a what is it called, right? So yeah, but I think this was great. Thank you so much, Arthur. Yeah.
I'd be like one question that was resonating in my mind the whole time I was reading through the chapter is really a question for you guys is have you found better ways of displaying proportions? Because it just felt like I was unsatisfied with every solution in a certain sense. Again, I'm not trying to say the author did a poor job. I think he's just trying to show the
Thank you.
things that you could use and that are effective in certain contexts, but I still kind of found myself wanting for more or for something better. I don't know if you've found anything or found anything in the wild or done anything yourself that you felt is a better way to do proportions, let's say in general cases.
The only thing I have to say really is, and you've touched on it a little bit, is for heavily nested proportions, like an interactive tree map. Like I build ours in Power BI, but I'm sure the same idea exists in any interactive dashboarding solution. Just making like an interactive tree map with like your first level of the hierarchy, and then you can drill down into either that specific level, or you can like I forget what the terminology is, but you could kind of like explode all the sublevels to see an even more detailed view. Um, is really I think the way to go for a large number of groups. But my only other thought, and I kind of like am taking this away from the Rwandan parliament government, I rarely have factors that have just two levels. But maybe what you can do is like, there's probably a term for this, but like group them. So I don't know, like I deal a lot with species. So maybe like mammals versus insects, or uh, terrestrial insects versus aquatic insects or something like that. Whereas before trying to group, we're trying to show bars for the like, let's say 10 different species would be a difficult thing. So yeah, just some thoughts I had.
Mhm. So one way where I stay inspired or find inspiration or I stay up to date with what people are doing to be honest with you, it's social media. So either LinkedIn or before it used to be Twitter, right? But now that it's ruined, I do Blue Sky. So they have, so I'm sure you guys are familiar with Tidy Tuesday. So that's a beautiful way to sort of start seeing what other people are doing, and then you can always find a way to apply it um, to your work. I usually favorite those posts and then I somehow either put them in my bookmarks or something like that so that then I can remember. Um, so that I think that's one of your questions, and that's like the easiest way for me to stay up to date with what people are doing. Um, the other one is when I read papers, to be honest with you. Um, to see how other people are doing it. But it's usually just social media. And Tidy Tuesday is such a good resource. And because it's a hashtag, you can just sort of go through that. Um, yeah, those are my thoughts. But yeah, I agree with you that the chapter is, yeah, it's like I want more. So this is a good introduction. So it's a good like way to start thinking about proportions and all the other ways that we have seen. But there's more to add to the conversation. So I agree with you.
Yeah. Yeah, one of my real struggles at work is kind of is this in a certain sense that people want to see all the things. And I think this kind of comes back to, well, like number one is like a problem. It's like you take the problem as it is, like, well, it'd be great if you could see by region, as you know, by region and within region, urban, rural, and maybe have other grouping variables, but then it just becomes a table of colors to a certain degree.
I think at this point, you can start thinking about dashboards because I think that before we had so little data and we used to just use 2 or 3 graphs to tell a story and that was it. But now that we have, like I worked my postdoc last year, we worked with millions of rows of data, millions. And I was like, how am I gonna summarize all of this? And I think maybe we have to start thinking about dashboards, right? Like one dashboard, different graphs to tell one story because the data is massive, right? So I don't know if that answers your question too, but
Yeah. Yeah, I kind of feel like I'm in Josh's case, where, or at least as I understood it, where it's like you know, I have to show stats by all 10 animals and like all the groups and all the rest of it. It's just like people want everything. And I guess it's this tension between people want everything and they want it to be pretty. But
Mm,
at the same time, I feel like it's problematic to produce those things unless there's a story, right? I'm very much a story first kind of data viz person. But it's a difficult. I feel like some of the tension around the proportions is that like that, you know, it's easy to compute proportions, and often you find these in tables, and people want to have the richness of these kind of like statistical tables, whether it's from a paper or other sources, but there's no magic wand that you can wave to just make it a beautiful single chart.
Do you by chance work in like a French speaking town? Like, are you much
No,
like
no, no. I work with like an international organization, so like I happen to
okay.
speak French, and so yeah, so I end up dealing. These are not real data. This is not anything real from work. It's
Mhm.
like I actually have this repo where I've generated fake data for Burkina Faso using the sizes from the census, so I could have fake data to play around with.
Gotcha.
Yeah.
Okay, cool. Uh, do we have presenters for next week, Gabby?
yes, Rhett, you're presenting next week, right?
Yes, it is me next week.
Yes, thank you. And then I think Josh is you, right? The following week?
Sounds right. Sounds right.
Yeah, I think so. So thank you so much,
It is June
everyone.
after.
Yeah, right. If I remember correctly. Then we're gonna have to keep looking for other presenters. But I guess that's it. Thank you so much, Arthur. This was great. I love the little drawing that you did to add to your slides. I love that. Like that's such an
Yeah.
aesthetic.
I've bookmarked Excala Draw because of you name dropping it a couple times. It's new to me.
I love how that looks. So thank you so much. Thank you guys. I will be seeing you in another book club or in this one next week. I'm gonna write